Okay, lesson 4 is titled Describing a Distribution Displayed in a Histogram. In this lesson, we're going to need to be able to look and see how to turn fractions into decimals and decimals into fractions. So we're going to review that here at the beginning. So if I have a decimal and I want to turn it into a percent, what I do is I multiply it by 100. Remember, percent means per 100, so that means I'm going to multiply by 100. In order to multiply a decimal by 100, since there's 2 zeros in the number 100, it just means you're going to move the decimal place to the right, because we're multiplying, 2 places. So if I want to turn this into a percent, 1, 2 turns it into the number 45, so it's 45%. With this one, if I move the decimal to the right 2 places, 1, 2 leaves this little hole. I'm going to fill the hole with with a 0 and turn it into 20%. Okay, so with decimals, it's pretty easy. Move the decimal 2 places to the right, and there's your percent. Now, with fractions, what I'm going to do with the fractions is turn them into decimals first, and then turn them into a percent afterwards. So if I have 5/10, there's 2 ways I can turn this into a decimal. I can do this by doing 5 divided by 10, or I can think of this as 5/10, or 5 in the tenths place. So in order to turn that into a percent, same as up here, take the decimal point and move it 1, 2 to the right. This creates a hole, and it becomes 50%. With 1/4, I can do this also a couple of ways. In my calculator, I can do 1 divided by 4, or I can turn this into hundredths and work from there like this. So equal fractions, times 25, times 25. 25 hundredths is the same thing as 0.25. Okay, again, divide numerator by denominator, or turn it into a fraction that has a decimal place value as a denominator. Turning this into a percent, take the decimal, move it 2 to the right, and it becomes 25%. Okay, so here it says in lesson 4, we investigated the head circumferences that the boys and girls basketball teams collected. Below is a frequency table of the head circumferences that they measured. Isabel, one of the basketball players, indicated that most of the hats were small, medium, or large. To decide if Isabel was correct, the players added a relative frequency column to the table. Relative frequency is the value of the frequency in an interval divided by the total number of data values. This value is written as a decimal. Okay, so in order to do this, you first have to find the total number of pieces of data, which we've done previously. And to do that, you start by taking your frequency column and adding them all together. So when we add those all together, we get 40. To find the relative frequency, what we are going to do is we are going to take the frequency and put it over the total. So 2 out of 40 were extra small. 2 out of 40. I'm then going to turn that into a decimal. Now, just a reminder, to turn a fraction into a decimal, I would take my numerator and divide by my denominator. So 2 divided by 40. This would give me 0.05, or 5 hundredths. So with the next one, small, 8 out of 40 were small. So 8 over 40. I would do 8 divided by 40, which would give me 0.20. For medium, 15 out of the 40 total were medium. So to turn that into decimal, 15 divided by 40. And when I put 15 divided by 40 in the calculator, I get 0.375. 9 out of 40 is the same as 9 divided by 40. And 9 divided by 40 gives me 0.225. 4 out of 40 for extra large hats is going to be the same as 4 divided by 40, which is 0.10, or 0.1. And then the last one, once again, is 2 out of 40. I already have that work done up here. So I have my answer. So now it says, what is the total of the relative frequency column? So if I were to add all of my numerators together, which is all of these numbers, I would get 40. When you add fractions, the denominator stays the same, so it's 40 out of 40. And 40 out of 40 is equal to 1. So the total of our relative frequency column is 1. Now, the only time that this is not exactly 1 is if you have to round some of your decimals, which you may need to do with some of the numbers that you're going to get. So we would say it's approximately 1. It's just around 1. And the reason it's not exactly 1 is that rounding that we have to do some of the time. So the next question asks, which interval has the greatest relative frequency and what is the value? So the first thing is there's two parts to this question. Which interval has the greatest relative frequency? So we're going to look at our relative frequencies, which are all decimals. So some of these are 3 numbers past the decimal, so I'm going to make them all 3 numbers past the decimal in order to compare them easier. Once I've turned them into the same length, all I have to do is look at the numbers that come after the decimal point and compare those. So this would be considered 50, 200, 375, 225, 100, and then 50. So out of all of those numbers, the one that's the greatest is this 375. So it's asking me not for this value right now, it's asking me for the interval, okay? Interval, interval. So the interval that has the greatest relative frequency would be 550 to less than 570. Now it's asking for the value of that. The value of that is your decimal. So this is where I would put the 0.375. Okay, so 2 parts to that question. The next one asks, what percent of the head circumferences is between 530 and 589? So 530 starts here, and it wants us to go up to 589, which would fall in this category. So basically they're asking, as they did up in the problem, for small, medium, and large hat sizes. So to figure out the percent here, what I'm going to do is I'm going to take my relative frequencies for each of those hat sizes, so that one, this one, and this one. And I am going to add them together. And then I'm going to turn that decimal into a percent. So to remember to do that, you take your decimal and multiply it by 100, which is just taking the decimal and moving it to the right. So it becomes 80%. You can also just turn the relative frequencies into percents first and then add them together. Either way, it's the same thing. So I would just move this 2 over and get 20%, this 2 over and get 37.5%, this 2 over and get 22.5%, and then add them that way to get the 80%. Either way will work. Okay, so example 2 says a relative frequency histogram. So now what we're doing is we're making a histogram based on that relative frequency column instead of the frequency column, which we did yesterday. So the players decided to construct a histogram using the relative frequencies instead of the frequencies. They noticed that the relative frequencies in the table ranged from close to 0 to about 0.40 or 40 hundredths. They drew a number line and marked off the intervals on that line. So that's the same exact thing that was done yesterday in the histogram. Same intervals, same everything. Then they drew a vertical line and labeled it relative frequency. So that's our difference. Yesterday we were looking at just plain old frequency. Today we're looking at relative frequency. They added a scale to this line by starting at 0 and counting by 5 hundredths until they reached 40 hundredths. So basically, if you think about this, they're really counting by 5s. So 0.05, 0.10, 0.15, 0.20, so 5, 10, 15, 20, 25, 30, 35, 40. They completed the histogram by drawing the bars so that the height of each bar match the relative frequency for that interval. Here is the completed relative frequency histogram. So they've already done all of that work for us. They just want us to answer some questions based on that information. So it's asking us to describe the shape of the relative frequency histogram of head circumferences from example 2. So remember, for shape, we would do this. Okay, so when we do that, this is actually considered slightly skewed right. So slightly skewed right, because skewed right. Okay, so basically it's kind of tapering down to these higher values over here. There's more bars over this way that are to the lower values. If you had said approximately symmetrical, I think I would actually accept that as well, but it is slightly skewed right. Isabel said that most of the hats that needed to be ordered were small, medium, and large. Was she right? What percent of the hats to be ordered is small, medium, and large? Now, we've already done this question on the first page. We looked at the small, medium, and large hats as falling between 530 to 589. We found those relative frequencies, which were the ones I'm writing down right now. Added them together to get the total, and then took that and multiplied it by 100. So it was 80%. So it's asking, if she's saying most were small, medium, or large, was she right? And we have 80% of the hat sizes being small, medium, or large, I would say that's most. So yes, she was correct.